we can get this algebra equation. For this algebra thing, we can get this transfer function. This is the ratio of y's to us. So for this transfer function also can be written as this. We can see here. It is the product of one order. So we can see the power of s plus j1. We can see here it is one order. It is one. Power of it is 1. We can see here the n equal to L plus K. This is the order of the system. The common system is okay, we can say the n is the order of the common system. Now, order Zi is zero of the system. We can say Zi. Let it is equal to 0. We can see here s plus j1, s plus j2, and s plus jm. j1, j2, jm also called the joules of the system. And K is the ratio where Pm by m. It is the gain of the system. We can say here this gain K. The K is the gain of the condensation or the condensation. And Pi is called the powers of the system. We can say what's the Pi, P1, P2, Pk are all powers of the condensation. L is the type of the system. We can see here this is the order of the system. N is the order of the system. Now this type is a system. Now the type is no bigger than order. That's to say L is less than not bigger than M. Not bigger than L. This is the type of the system. And this is the order of the system. We can say these powers and those are neither real or form complex conjugated parts. We have studied in our mathematical courses. Now, the conjugate parts, complex conjugate parts. It is for real number coefficient equations. Also, we will have this parts. Now, the character of this transfer function, we have the following several. The transfer function of the system is a mathematical model. It is an operational method of expressing the differential equation that relates the output variable to the input variable. Second, transfer function can't provide any information concerning the physical structure of the system. Transfer function of different systems can be identical. So we can say it is tell us the transfer function of a computer system. The transfer function is a model, a mathematical model. We have asked you what's the meaning of mathematical model? What's the meaning of mathematical model? The first class I also asked you, remember? Mathematical model, what's the meaning?
Model. Mathematical equation also.
Relating among or between variables. The second, transfer function cannot provide any information concerning the physical structure of the system. It is many different systems can be identical. If you see, if for an electrical system or a medical system, maybe they are the same. In fact, there are two different systems, but the transfer function is the same.
So mathematics model is linear or non-linear system, time varying or inverse system or sequence or time discrete system.
For the transfer function, it is only related to linear system. For non-linear system, it cannot treat.
So this is mathematics, but this is also related only linear in terms of function.
The third, the transfer function is a property of system itself, independent of the magnitude and the nature of the input or driver function. It should say the transfer function reflects the system itself, not related to other, such as input, output. And the fourth, if the transfer function of a system is known, the output or response can be studied for various forms of inputs with advice toward understanding the nature of the system. Transfer function may be established experimentally by introducing known input and studying the output of the system. And the sixth, transfer function gives a full description of the dynamic character of the system. And the seventh, the transfer function is defined only for a linear system, and strictly only for time invariant system. Time invariant linear system. So it's very strict. The condition is very strict. So we only start the time inverted linear system. Okay, let's go. For the transfer function, now it is the natural transform of the impulse response and vice versa. Next, this transfer function can be written as ns by ds. What's ns? Ns is characteristic. It is polynomial, and ds is characteristic equation. It is the root is the powers, and if ns equal to 0, now the root of ns to 0 is called zeros. Next, we should start block diagram representation. Now, it is very important and should pay attention to it. Last class we have started some of it. Now we should go on. The block replaces the function or dynamic characteristic of the component, and it is represented by a transfer function. So the block diagram is respected by transfer function. We can see here. The second, the complete block diagram shows how the functional components are connected, and the mathematical equation that determine the response of each problem. Now, this is the characteristic of block diagram. We can see here for a block diagram there is some symbols for it. Here, this is the subjective we have studied. Tell you how last week. This is also we call it arrow. Also branch front. We can see here this arrow. This is branch front. Now this is block. Where is block?
GS.
This US is input, YS is output. So for this block diagram, there is some name of this we should remember. Here, block diagram algebra. You can see there is several rules for it. And for this, we can see here, what rule 1, combine several blocks. Second 2, combine parallel of blocks. Rule 3, closing and feedback loops. Rule 4, move and sum junction ahead of block. Rule 5, move and sum junction past a block. Rule 6, move and branch or pick up point ahead of block. Rule 7, move and branch point past a block. Now, for this several, we showed now how to do it. Here, the first rules. Combine several blocks, also associative and commutative properties. We can see here. This is block diagram. We can see here. The first rules. The several blocks successive to each other. We can see here. Now, then the transfer function of the system equal to the product of arbitrary blocks. So the compensation, the transfer function of the compensation system is equal to the product of each of the transfer function of for every blocks. So this GS equal to the product of GIS, where I equal to 1 from 1 to n. So the first rules tell us how to do. Now this means it equal to products of every transfer function. It is very simple. Set. Now the transfer function parallel to each other. Now, what's the complex system? What's the transfer function of the complex system? Now, here the complex system is
Z1 plus Z2 plus Z dot 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 n.
is summing of this every transfer function. How to reference it? How to reference it? You can see how to give the result. How to give the result? What's the transfer function of commutation? Now we can see here for the input is R. The input is for every transfer function. It is the same. Also R. But the output for the first block it is C1. And for the second block it is C2. And for the natural the GM transfer function GM, the output is the same. So we can see here the output of the complex system is the same. The C equal to C1 plus C2 plus 2 Cm. So we can see here the C equal to C1 plus C2 plus Cm. Now then C1 equal to G1R, C2R plus G2R.
Zn, Rn.
So equal to G G1 plus G2 plus Gn
times
R. So the complete system, this transfer function of the complete system equal to C by R. So equals G1 plus G2 plus Gn. So the transfer function, if the block is parallel to each other, then this transfer function of the complete system is the sum of the array blocks. Okay.
happiness
G1 input output is
Any questions? No. We can also, for this, we will also can,
okay.
again, we can, how to get this result?
Series.
We can see here, this is the C1, C2, and this Cn is to C. So we can also do like this. Let's C1. How to do C1? C1 equal to G1 times R. With C1 equal to G1 times R.
why log G1 times R? I can understand.
It's the definition of transfer function.
Ah.
Transfer function equal to C by R.
Yes.
So this C equal to G times R.
It's formula log.
So
One teacher would not teacher.
okay, let's go. Now C1, number C2. C2 equal to what?
G2 R.
So for the C2, C1 is the input of C2. The output is for this block 2 is C2. So the C2 equal to C1 plus G2.
G2.
Because C1 equal to G1 and R G2. So equal to G1 G2 R.
Again.
So again, this Cn
Now she repeat again.
Cn equal to
This was
Cn minus 1. Then Gn. So equal to G1 G2 Gn R. Because C equal to Cn. C equal to Cn. So the transfer function of the complete system is C by R. So equal to G1 G2 Gn. So this is how to give the result. Now here, this is a closed feedback. It's used very commonly. Now it is for the complete system. This is a closed loop complete system. Closed loop system. But we can recognize it as this open loop complete system. Common to this. For the closed loop complete system, its transfer function is written as phi s, not gs. Gs will only this transfer function is phi s, it means closed loop Coulomb system. Now, how to get this result? Would you like to do as me? How to get this result for this closed loop Coulomb system? How to?
Using good component.
How to by this block diagram and get this transfer function is here. From this block diagram, can you see here this GS, it is the open loop Coulomb system's transfer function. If here there is a feedback rules, so for this path, it is this system is closed loop Coulomb system. So its transfer function is written phi s. It is differential with GS. So now how to get this formula? Here E and big E and big B is help us to get this result, but it is not useful. In fact, it is linear variables. We should remember the transfer function of Coulomb system is the equal to Cs by Rs. Remember this. It is the target. We should have got these two. This ratio of R to Cs to Rs. Now we can see here in this system, we can get many equations. First, E equal to what? E equal to what? E equal to R plus and minus B. First, and C equal to what? C equal to
E plus E minus
E
minus
times GS times GS. And B, what is this? B?
B equal R minus E.
B equal
No. B equal
to C times HS.
H's.
So here we showed this B. Then this plus to here now equal to R plus and minus C times HS. So this E equal to R times and minus C GS. Now, it is equal to R GS and hence plus and minus CHS and GS. This C also says R is eyes, and put this part, move to this node. It is also C equal to. Then this is C, the plus become minus, and this minus become plus. So here C, H is GS equal to R GS. Here we can see there is C, here is C. So it can write as C is put forward and C equal to 1 plus 1 minus plus. By the definition of transform function, then the closed form system, the transform function of transform function of it is written as phi s. Phi s also is the C by R. C by R. So it equal to, we can see C by R means like divided by R.
So Z is over 1 plus 1.
So this part is moved to this here. So equal to GS by 1. Here is minus plus GS. It is here. Why? Here this is minus and is on up, and this plus is down.
This is side
Because you moved from
left to right.
right to left.
Right.
Oh,
Right to left. So the
Yes.
symbol should be changed.
yes.
Yes. Now, you please look at this blackboard and quitting. Can't not understand this one. It's also the meaning of transform function.
I know, but I can understand something.
What kind of understand? Do you understand that?
But it didn't understand this one.
Do you understand that?
Not this one.
Oh, that's good.
Yeah.
But are you understand it? Yes. We remember this transfer function, the definition. For the definition, the transfer function is this GS equal to CS by RS.
Yeah.
Maybe we are so for this block, H is the GS, and the input is C, and the output is B. So B, the ratio of B to equal to x. So B equal to C times x.
Yes, Lord.
The same as C. C. The first one, any question? Is the meaning of this subjunction? Because
Yes.
this is the subjunction. Here is plus and minus means R plus or minus B equal to E. This two is the input and this is the output.
This summing junction.
This subjunction. Subjunction. Oh, okay. You can read it or look at it for some minutes and discuss it.
Okay, Lord.
Okay.
Equal to R minus. Summing junction is R minus. 가운데 문 앞서 우리가
What? Easy. If you have any question, you can ask monitor after class. Okay? He thinks it's very easy. Now, let's go. This is an example. How to build the mathematical model for this system. Now, begin. You can pick up your Excel book and do this exercise.
For the exercise book, Nani, this is my notebook.
Notebook.
It's also exercise.
You can for the class. You can use it for the exercise book.
Yeah.
Oh.
Seriously,
Jumper. Sabi.
Do you know this new coronavirus tagging in China? You know
What?
coronavirus register tagging in China?
In China?
Yeah. Qingdao city, Shandong province.
Jingdong?
Qingdao.
I have never heard of this.
This Sangsha city is from today in school students to wear masks.
Martha.
Yeah, this is school. Not this school. This military school and primary school. High school, I mean.
You have Balsa from Jingdong?
This means
We mainly discuss the lessons, not other Jingdong. So it is we have class.
but
It's not
important.
coming.
It's important.
Even very important, but it have nothing to do with our class.
Yes.
So it is not permit in the class
I think
discussing. So
I will go see.
We should concentrate in our course. Whatever you want to do.
Now she, this come,
आपने कैसे करना
This is C is for cross.
Yes.
This is C for up, forward. This is C, part 1 is C. Minus plus H is GS equal to R GS. So this one is here. Is C.
And then
This for the closed loop conversation, the transfer function is right as phi s. Phi s equal to cs by rs. For the okay.
itu tuh easy ya, jadi kalimat boleh.
For the in fact it is a differential equation. It is use a lot of transfer function. So it is have this dash. Look, directly use this physical principle. Okay. For this this I is equal to what? Remember, I2 equal to what? Equal to this
1 over here.
I1 is R. 1 so equal to I2. This differentiation of
Capacitance.
yes, you can use the Laplace transform. We can get this equation. Any question for this equation. If not, we continue. For your electricity students, it will be very easy for you. Now, oh, too much. How to do? Oh. Now, how to divided it into this let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the vector equation. UR minus UC equal to I1 R1. You can see UR minus UC equal to I1S R1. Okay, this is the first one. The first. This is the first equation. The second equation is UCS equal to ISR2. You can see UCS equal to IS times R2. The second equation.
Yes.
And this is the third equation. The third equation, you can say I1S times R1. Now, times R1. Now, it is equal to CS and IS. We can see here, this I1S times R1 times CS equal to I2S. It is the same if this for this equation right and left times CS at the same time. So we can get IS also equal to I1S R CS.
I1 into I1.
Is with here I2S CS equal to I1R and I2 also equal to I1R CS. So for this, the third picture of this is the is the third equation. The third equation. And NASH is this I1 plus I2 equal to IS. So the formula is consists of four block diagram. Now NASH we can consist only one block diagram of this RC network. You can see here. This is I equal to plus 1, I1 plus I2. Yes, this I2 equal to I1 times R1 times CS. And this I1 equal to what?
1 by R.
It is UR minus UC and times 1 by R1. And also we consider and this is footwork block and this is the footwork. This is the black word. So this two is different. The word this arrow is the direction of the arrow is not the same. Now we should study this powers and zeros of this transform function. Effect of zeros and powers of the transient response. signals. They are main factors which affect system's performance. Now we can see here poles and zeros in the complex plane. You can see here the red symbols is poles and the blue symbols is zeros. Now zeros and poles are all on this complex plane. Here zeros determine the scales of each modality, which is shown in the response. Sometimes they can interdict some modality being complex input to be transferred to the output. And the conclusion is poles and zeros determine the system's dynamic performance. So, for the system, we should analyze the zeros and the poles of each. For the transfer function, we should study the closed-loop computer system. And this block diagram will help us to analyze this transfer function. Now, for block rules, we should study how to simplify the block diagram of a complex feedback computer system. It's very important. Should simplify the block diagram. And also to rearrange the block diagram based on some in usual rules. And also for this precondition in variable or equivalent, we should predict these variables. Now, next, we should ensure to maintain output of rearrangeable blocks. Now, we can see here, this is the rules of the systems, the force rules. We have studied we see here, three rules. The third rules. And the fourth rule is move and semi-junction, a handle of block. You can see here is the block and this is the semi-junction. If you move this semi-junction forward to this block, then how we change this to make it the output is the same. We should not change the output. Any question? Okay, let's have a rest and you can discuss